Hello, today we're going to factor a trinomial with a method I guess you could call AC and a GCF shortcut. So likely, I'm not super fond of shortcuts usually because it's, you don't see the math behind it. But if you're really struggling with factoring and you're just trying to make it by, then you might want to give this a try. So let me get this all going here. We're going to factor the trinomial 6x plus 7x plus 2. And this method begins by, as many of the methods do, again, this is only applicable to those trinomials with a GCF, with a leading coefficient that is greater than 1. Here we have a 6, right? Again, if the leading coefficient is equal to 1, then this is a much easier situation. So first thing we're going to do is, this is in the form ax squared plus bx plus c. So we're going to take advantage of the AC part of this method, which is multiplying a times c, which is 12 factors of 12, that add to be b, which is 7. And of course, we're going to get a 4 and a 3 here. 4 times 3 is 12. 4 plus 3 is 7. And in this method, what you do is you rewrite the leading term, so the first term, so 6x, but we take out the squared, okay? And again, this is where it's not super mathematically sound. It's a trick. I'm not super fond of it, but it's okay. We're going to then put the 3, so this 3 right here, undo. This 3 and this 4 are coming into play right here, so the 3 and the 4. But what you do is you write it as 6x plus 3 and 6x plus 4, and these become binomials. Now, as you can see, these have no meaning mathematically whatsoever right now, because if I were to distribute these out, I'd get like 36x squared plus 24x plus 18x plus 12. It's definitely not great. So what I'm going to do, the last step is to take each of these. And then this is where the GCF part of this is. You divide by the greatest common factor of each one. So the greatest common factor here is 3. The greatest common factor here is 2. When I divide both terms by that GCF, 6 divided by 3 is 2x. 3 divided by 3 is 1. 6x plus 4 divided by 2. 6x divided by 2 is 3x, and 4 divided by 2 is 2. I'm going to show one more of these. A lot of people like this. Again, it's a shortcut. It's not super mathematically sound. Probably tired of hearing me say that. Let's try 6x squared plus 13x minus 5. And when I say not mathematically sound, it's not true. I mean, I am doing things that are sound because of the different properties I'm using, but I think there are methods that help us see more what we're doing. It's okay. Stop talking, Mrs. Golding. Just do it. Okay, so AC part of the method, A times C equals B. 6 times negative 5 is negative 30. B is 13. You can think and think and think, and you're going to get a positive 15 here and a negative 2 here. And you're going to then rewrite this again. So the first term you're rewriting, but without the squared. Okay, you're just taking it down to an exponent of 1. 6x plus 15, okay, binomial, and 6x. So you're repeating that 6x, and then minus 2. And once again, the 15 is coming from right here, and the 2 is coming from right here, negative 2, because positive 15 times negative 2 gives me negative 30. Positive 15 minus 2 gives me that 13, which is this middle term right here. Okay, and 6 times negative 5 is where this is coming from. Okay, the last step is that we're going to divide by the GCF, greatest common factor in each. We'll see. 6 and 15 have a 3 in common, right? As their common factor. 6 and 2 have a 2 in common. 6x divided by 3 is 2x. 15 divided by 3 is 5. 6x divided by 2 is 3x. Negative 2 divided by 2 is a negative 1, and we have factored it. Again, it's a nice shortcut. It does work for trinomials in standard form with the leading coefficient greater than 1. Again, if you like this, take it. If you don't, leave it.